This is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University-Surampalem. Today we would like to discuss about the topic registers. Coming to the learning outcome of the registers, so at the end of this lecture, students will be able to understand the operation of the registers and use them for storing and transferring binary data in digital systems. Coming to the registers, a register is a group of flip-flops, each one of which is capable of storing one bit of information. So here the register contains basic building block, that means flip-flops are the basic building blocks for the register. Now each flip-flop can be stored only one bit of data, either it may be 1 or 0 digitally. So that means one flip-flop can store a data of like binary bit either 1 or 0. So here an n bit register consists of a group of n flip-flops capable of storing n bits of binary information. Here n bit register means the register contains n flip-flops. So for n flip-flops, n bit of data that can be stored in the n bit registers. So there is a capability of n bit registers, that means n bit group of bits that can be stored in the n bit register. So n bits of binary information that can be stored is the capable of that particular register. In addition to the flip-flops, a register may have combinational gates that perform certain data processing tasks. So in addition means, so again a register is a combinational gates that perform certain data processing tasks also. A counter is essentially a register that goes through a predetermined sequence of binary states. So the construction for registers, counters are almost same. Depending on the flip-flop construction only, these two whether the registers or counters may differ. A little difference between these two, register or counter. The gates in the counter are connected in such a way to produce the prescribed sequence of states. So we discuss all these things in the next slides. Now this is a 4-bit register. So you can see that this is a construction of 4-bit register. So for a 4-bit register, here we are using 4 flip-flops. So 1, 2, 3, 4 flip-flops. That too, these all are D flip-flops. So DFF, representation of this flip-flop is DFF. Now the first D flip-flop, we can call this one as a DFF0, and this is DFF1, and this is DFF2 and DFF3. So this is the simple representation of these 4 flip-flops starting from DFF0 to DFF3. Now the input for this particular D flip-flop is D0 for the first stage. Here we call this one as the first stage, and here we call this one as the second stage, third stage, fourth stage. For first stage representation, D0 is the input and Q0 is the output, and second stage D1 is the input and Q1 is the output. For third stage, D2 is the input and Q2 is the output, and D3 is the input and Q3 is the output for the fourth stage. So likewise we have to increase the stages of any register or counter like this. But all these flip-flops are connected in only one way, through the clock signal. Here the clock is the controlling part. Most of the time for flip-flops, clock we call that one as a edge triggered clock. We use that edge triggered because here most of the time we are using this clock signal, that is either it may be up or down. So let us consider, so this is the signal, so mostly we call this one as a clock signal. So if this one is rising, we call this one as a up, this one is a down or falling. So this one is a head, this one is a tail. So likewise there are so many textbooks that representation is like that. So we call this one as a up triggered, or we call this one as a pause edge or positive edge, this one as a neg edge or negative edge, neg edge or negative edge. So depending on this one only, this clock signal is controlled entire device. So once this clock signal is connected to all the clock signals of the flip-flops, So then these all flip-flops are in synchronous. So we call this one as a synchronized circuit, or these all flip-flops are in synchronization. That means if we change the clock signal, that will change all the clock signals in the flip-flops. So likewise, this is a simple construction. So this is a 4-bit register. So all the flip-flops are connected by a single clock signal. So here construction of 4-bit register using D flip-flops. So here D type flip-flops are used, and these all are clocked input trigger. All flip-flops are on positive edge. So this thing is again explained here. Now coming to the buffer register. So buffer register is a simple, the construction is very simple. Here from right side to left side, we are simply using, this figure shows the from right side to left side. So buffer register is nothing but, so the same construction. So here the inputs are B0, B1, B2, B3 are connected to first stage, second stage, third stage and fourth stage. So these all are the outputs Q0, Q1, Q2, Q3 are taken. So once we will take the outputs Q0, Q1, Q2, Q3, then the outputs we can take the 4 bits at a time. That means 4-bit input we have given and 4-bit outputs we are taken. So at the same time. So this is a 4-bit register because we are using 4 stages. So we are applying the input and we are taking the output. So depending on these inputs and outputs, we call this one as a parallelism. So this one also we can see in the next slides. So this is the consider the data is to be stored in B3, B2, B1, B0. So that is 101, a simple operation. This is a simple operation, that is 1010. That means B3 is 1, B2 is 0, B1 is 1, again B0 is 0. So that 1010 that can be directly assigned to, because according to the D flip-flop, so Q is equal to D when clock signal is enabled, clock signal is high or enabled. That means Q is equal to D. So likewise Q3 is assigned to, that is B3 is assigned to Q3 and Q2 is assigned to B2, Q1 is assigned to B1 and that B0 is assigned to Q0. That means equal, both are equal, Q is equal to D. So here the inputs are directly 1010. So that 1010 that can be assigned to, so Q3, Q2, Q1 and Q0. So this is the data that can be, we can access the data from Qs, that is outputs. Now, so apart from that, registers, shift registers are also there. So shift registers means simply the data is shifting by one flip-flop, like 1 to 1. So here a register capable of shifting the binary information held in each cell to its neighbor cell. So this is called shifting. So now n-bit registers will consist of n number of flip-flops, as we know already. So if there is n number of stages, definitely so n flip-flops we require, and the binary data in a register can be moved within the register from one flip-flop to another flip-flop. So that is the, we call this one as a shift register, data transfer shift register. So here it contains again 4 modes of operations of a shift register. Simply we call this one as a serial input, serial output. So SISO, shortcut we call this one as a SISO, serial input, serial output, and serial input and parallel output. So SIPO is the shortcut, and parallel input and serial output, that is PISO is the shortcut, and parallel input and parallel output, that is PIPO is the shortcut for all these shift registers. While coming to the serial input, serial output, there is a right shift and left shift is also there. Depending on the construction only, we can shift the data from right to left or left to right. So that is the advantage for this SISO, that is serial input and serial output. Now this is a simple figure that shows all the data shifting. So like basic data shifting in shift registers. So if we observe the first figure, so data is from left, that means input is from left and output is that is shifted to right. Here the input is that is shifting from left to, that is right to left here. Now here the data, the parallel data we are giving and we are taking the sequential, that is serial data output. Here the data is input, that means serial input we are giving, the data is in serial, but the output taken is a parallel connection. Now here the data input is parallel, at the same time the data output is also a parallel. So we already discussed this one, and this is we call this one as a rotate right. So that means from left to right the output is shifting. Again the final stage of the right side, that output is again given to the input of the first stage. So this is the left to right rotational, and here this is right rotate left, that means from right to left, that means from right side the input is given, and finally we are getting output at the left side, last stage of the left side, and finally that output is given to the input of the first stage. So likewise this is a simple figure, so it shows all the data transferring or shifting from one flip flop to other flip flop within this modes or within this format. Let us discuss the first concept, that serial input and serial output. So serial input and serial output register, that too this is a left shift register. So left shift means we have to apply the input from the right side. So from right side to the data is moving to left, that is why we call this one as a left shift. So there is no change, we are simply applying the data input for the first stage, that is D0, for the first flip flop DFF0. So the data, the output Q0 is connected to the D1, that means the output of the first stage is given as the input to the second stage, so that is D1. So directly the data is given, and second stage output given to third stage input, and third stage output given to the fourth stage input, and finally we will collect the output at the fourth stage. So that means this is a simply that is why we call this one as a SISO. That means from right to left we are shifting the data, and finally serial data we are giving and serial data we are taking. That means this is a serial input, serial output data. So this is shifting. So the truth table, whatever it is showing, is a simple shifting of the zeros and ones from right side to left side. So for each clock is enabled. If clock is enabled means up arrow is enabled. So for each clock, so one clock pulse is there, then the data is shifted from right side to left side. So we can easily shift our data from right side to left side. Each and every flip flop is transferring the data likewise. Now coming to SISO, that is, this is the right shift. So you can able to shift the data according to the figure. So the data is shifted. If we concentrate on that particular 0, so that arrow represents the on 0. So the data, so for first clock cycle, that 0, so that means the first D flip flop is of having the data, that is 0. So now for first clock pulse is, this is the clock pulse. Now first clock pulse, the data will appear at the here, so that is Q3. Now the second stage is of having the data, that 0 here, that means the same 0 is applicable at D2. Again for second clock pulse, so the D2, the Q2 is the D2, now that same 0 will appear here. And for third clock pulse, here two clock pulses are there, so the third clock pulse, so D1 is of having the data 0, that same 0 will able to apply here, that is at Q1. So because Q1 is equal to D1, so third clock pulse, it will be, the data will be at the Q1. Now the same 0 is the input for D0 for fourth clock pulse. So again for fourth clock pulse, so D0 is of having the data, that is 0. So now finally our output is 0. That means here we are applying the serial input, because this is a serial input, and we are getting the serial output. So the whatever the 0 as the input we started, so we are getting at the output side that same 0 after completion of 4 clock cycles, that it represents like this. So this is the 4-bit shift register, and that too this is a serial input and serial output. So you can able to see that 0 that is moving from starting, that whatever the data 0 0 1 1 0, that is the input data given at the input side, and after the clock pulses the entire data is shifted to the right side. So likewise this represents a simple representation of the particular SISO, that is serial input and serial output. That too this is right shift, from left to the data is shifted to right. So SIPO, so this is a simple serial input, parallel output. So the data is given in the serial, that means if the data is 110, 1101, so the first one will go to here for the first flip flop, and later second clock pulse, so that 0 will appear, and the third clock pulse 1 will appear, and the fourth clock pulse this one will appear. So that means after 4 clock pulses, so this one, whatever this one will be appeared here, and the second one will be appeared here, and the third 0 will be appeared here, and the fourth one will be appeared here. So that means for fourth clock pulse, all the flip flops is of having the data whatever we are giving as a serial. So that means all the data is in serial. So now after connecting this, after applying this example data, now we will get the QA, QB, QC, QD are taken at the output side of all the flip flops. So that is why, so we can take directly. So once we enable the clock signal, so the 1 will appear here, and this one will appear here, and this one, this 0 will appear here, and final 1 will appear here. So finally that 1101 we can use this one as a, apply this one as a serial, but we can collect this QA, QB, QC, QD the same output, that is 1101, that after 4 clock pulses only. So likewise we can use this serial input, parallel output. So this is the other shift register. Now coming to PIPO, that is parallel input and parallel output. So we have to give the input data parallelly. So this is a 4-bit register, that means 4 flip flops we are using. Now the data is given parallelly, that is already input is applied parallelly. At the same time we are taking the output at each and every stage. So we call this one as a parallel input and parallel output. That means input is given parallelly because it contains the data input like 1101 for 4 flip flops, and again output is also 1101 after a single clock pulse. So within single clock pulse we will get all the outputs. This is the advantage. So most of the time we can take this one as an advantage for the GPUs. So present nowadays GPUs are also used in the computers. So the parallelism we want actually. So for parallel simulation, so these GPUs are working. So now a system that contains CPU with GPU will give you the results fast, so for this particular simulation. So for that particular GPUs, so these type of structures we want. Next, parallel input and serial output. This is also one type of register. So now we have to apply the parallel data. So at the same time we have to apply D0, D1, D2, D3, and finally we will get the serial output one by one. So this is a simple construction of the circuit. That entire circuit is of having 4-bit data, that is 4 flip flops. For 4 flip flops, so we have to use that either shift or load bar or shift. So depending on the data, that means we are applying the first data, but actually the second, whatever the D1, it completely depends on the logic. We call this one as a particular logic. We already checked this one in the first slide. So the sequence of the flip flop with the logic. So this is the logic, that logic combinational circuit. This is the combinational circuit. So we are simply connecting to all the flip flops. So depending on this data, we are connecting these data to all the 1 AND gates, and finally the output of the previous stage is given to the AND gate, one more AND gate, and finally we will connect this entire thing to the next stage. So that means D3 is indirectly depends on the Q2, D2 is indirectly depends on the Q1, D1 is indirectly depends on the Q0. So anyway, the clock signal is common for all the flip flops. Here we are connecting the clock signal common, and finally we are taking the output at the last stage, because here we have to prove this parallel input. That is why 1101 data we are simply entering into the input, and finally we are taking 1 1 0, 1. Likewise, this is a serial output we have to take. So, this is the parallel input and serial output structure. So, entire thing depends on the this shift condition. So, if it is 1, so one signal will be enabled, and if it is 0, the other signal will be enabled. Those two connections are connected to, so one of the terminal of these AND gates. So, depending on these AND gates only, we will get the output. That means the output is 1 when both the inputs are 1. The output here also 1 when both the inputs are 1. Finally, these are the OR gates. These three are the OR gates. So, if any one of the 1 is 1 or any one of the or both ones are 1, both inputs are 1, then the output is 1. So, likewise, we have to analyze this circuit, and finally, the D1, D2, D3 are indirectly connected to Q0 and Q1, Q2. So, this is the construction of parallel input and serial output, that is the resistor. And this here the shift is 1, load is 1. And coming to the advantages, here the advantages for I have given for both resistors and shift resistors also. So, most of the time can store multiple bits of data simultaneously and provide fast data storage and retrieval. That means we can apply and we can take the data also. Simple control using clock, because most of the time we are using the entire process depending on the clock signal only. And essential for data transfer and temporary storage in digital systems. Most of the time we want that shift registers, because in order to shift the data from one place to other place, most of the time these circuits are used in the architecture of the CPUs and GPUs. Now, capable of serial to parallel and parallel to serial data conversion, because this is the advantage of the shift register. And simple and cost effective design, because it is construction is very simple, depending on the flip-flop stages only, the construction is very simple, and useful for time delay and sequence generation, easy implementation with the help of using the flip-flops. So, coming to the disadvantages, so limited storage capacity compared to memory units. That means, so if the flip-flops are limited, definitely the stages are also limited. So, that is why, so if the this is a great disadvantage for this particular registers, and require more hardware as the number of bits increases. So, we want to construct more hardware, because if the number of bits are increased, definitely hardware requires. Power consumption increases with size. So, that means simply if size is more, power is also it consumes more. So, not suitable for long term data storage. So, we cannot store more number of, that means long term, and data shifting is slower compared to parallel transfer. So, this is also one of the disadvantages for this particular registers. More clock cycles required for large data widths. So, as we know already, so this is a synchronous circuit, that is fine, but if it is asynchronous circuits also there, so definitely it requires more clock pulses. And improper initialization can lead to incorrect outputs and limited to flexible for complex operations. And coming to the application part of the registers, so temporary data storage in CPUs, that is very essential for CPUs. So, temporary storage we can use for this particular part, and holding operands and intermediate results in the ALUs, and instruction registers and data registers in the microprocessors. So, because of the register is a memory element, so we can store all the data, that is either 0 or 1 in the one flip-flop, and buffer storage in digital systems, serial communication, and data transfer and buffering, and counters like ring counter and Johnson counters, and sequence generators and time circuits, arithmetic operations like multiplication and division by powers of 2. So, these all are the application part of the registers and also as well as shift registers. So, coming to the summary, so registers are a group of flip-flops used to store multiple bits of binary data simultaneously. They play a crucial role in digital systems by temporarily holding data, instructions or intermediate results during processing. Registers enable fast data access and are fundamental components of processors and control units. Coming to the shift registers, so registers is one of the shift registers are one of the type of registers, special types of registers that can shift stored data either left or right on each clock pulse. They are widely used for serial to parallel and parallel to serial data conversion, sequential generation and timing control. Due to their simple structure and versatility, shift registers are essential building blocks in the digital communication and control systems. Thank you.